Hello everyone, welcome back to my channel. Myself Aishman, pursuing my Bachelor's of Engineering at Sri Venkateshwara College of Engineering, Bangalore. Today we will be studying about the course Mathematics or Applied Mathematics. We will be covering the topic Vector Calculus in Computer Science or use of Vector Calculus in Computer Science. Now let's start our slide. The first slide which shows us Introduction to Vector Calculus, that what is Vector Calculus. Vector calculus is a powerful mathematical tool with applications across computer science, physics, and engineering. It provides a framework for analyzing or manipulating multidimensional quantities, enabling the study of dynamics, optimization, and complex geometric phenomena. Then, vectors and vector fields. Vectors are the mathematical objects that have both magnitude and direction, represented by an arrow in 2D or 3D space. Vector fields are functions that assign a vector to each point in the space, describing the flow or movement of a quantity like wind, fluid, or electric field. Operations like addition, subtraction, and scalar multiplication can be performed on vector to analyze their properties and relationships. Here, these are the vectors and vector fields. Then we will studying scalar and vector functions. What are scalar functions and then what are vector functions? Scalar functions map variables to a single value, while vector functions are map variable to a vector or a collection of values. Scale functions are useful for modeling quantities like temperature or density, while vector functions are represent more complex phenomena like electromagnetic fields or fluid flow. Then understanding the properties and behaviors of the scalar and vector functions is an essential for many areas like computer science, from graphics and simulations to the optimization and machine learning. Here, next, the main, we can say, a part of a vector calculus is gradient, divergence, and curl. These three topics are majorly covered in our syllabuses or in many questions. Like, what is gradient? Gradient of a scalar function measures the direction and rate of change of the function at a given point. It is a vector field that points in direction of the greatest increase of the function, while divergence of a vector field measures the density of the outward flux of a vector field from an infinitesimal volume around a given point. It describes how field is moving away from that. Then curl. The curl of a vector field measures the density of a rotational component of the field. It describes how a field is rotating around a given point. Curl is important for understanding fluid dynamics and electromagnetism. Applications. These vector calculus concepts are essential for modeling and analyzing vector fields, which are fundamental in areas like computer graphics, image processing, and computation physics, etc. Here we studied about the three topics of vector calculus, which are gradient, divergence, and curl, and some of them applications. Now, line integrals and path independence. Line integrals. Line integrals measure the work or the flux along the path in a vector field. They are useful for computing quantities like circulation and electric potential. Then path independence. If a line integral is path independent, it means the value only depends on the start and end point, not the path taken. This is important for conservative vector fields. Then Green's theorem. Green's theorem relates line integrals around the closed curve to a over region enclosed. It generalizes the fundamental theorem of vector fields. Surface integrals and flux. Surface integrals measures the total flux of a vector like electromagnetism, fluid dynamics, and thermodynamics, where understanding the flow of quantities like charge or momentum and energy is essential. Like surface integrals use the major electromagnetism, fluid dynamics, thermodynamics, and in this topic we understand the flow of quantities like momentum and energy is essential. The flux of a vector field through a surface is calculated as dot product of the vector field and the surface normal integrated over the surface area. This provides a way quantity or quantify the amount of the vector quantity passing through a given region. Then Green's theorem and Stokes theorem. Green's theorem. Green's theorem in vector calculus. relates the double integral of vector field over a region to the line integral of the same vector field around the boundary of that region. Then Stokes theorem relates the surface integral of the curl of a vector field over a surface to the line integral of the vector field around the boundary of that surface. Then applications. These theorems have important applications in computer graphics, electromagnetism, and fluid magnetism, and fluid dynamics, enabling at efficient computing of integrals and analyzing the vector fields. Then applications in computer graphics. Applications of vector calculus or applications of vector in computer graphics. In what ways the vectors can used in computer graphics or graphical applications? Vector calculus plays a crucial role in computer graphics, enabling the representation, manipulation of complex 3D shapes, surfaces, and fields. Gradient divergence and curl calculations are essential for realistic lighting, shading, and rendering effects. From fluid simulation to deformable objects modeling, vector calculus provides the mathematical foundation for the advanced graphics algorithms and techniques. Its applications extend to animation, visualization, and computer-aided designs. Majorly, where is the vector calculus used in computer graphical applications? Like we have studied in subject CAD, computer-aided design is also in vector calculus subject. Then animation, visualization, graphics like cartoons are made. Major parts, in various parts, the vector calculus is used. Then optimization problems in computer science, resource allocation, network routing, machine learning models, software design. There are 4 points mentioned in optimization problems in computer science. Efficient resource allocation, efficiently distributing the computing resources like CPU, memory, and storage to maximize performance and minimize the cost. Then network routing, finding optimal paths for data packets to travel through a network, balancing factors like latency, bandwidth, and congestion. And machine learning models, using the hypermethods of machine learning algorithms to improve the accuracy, generalization, and training efficiency. And software design, optimizing the code structure, data structure, and algorithms to enhance the speed, scalability, and maintainability. This all was in the slide in the vector calculus, that where vector calculus is used in our daily life, computer science, in computer science stream, in computer applications, in various computer science, we can say programs and all. Then conclusion and future directions. And what is the conclusion of the slide and what are the future directions of the vector calculus in the computer science? In final section, we summarize the key insights from our exploration of vector calculus in the computer science. We also look ahead to exciting future applications and research directions that hold the great promise. That's all for today's slide. Thank you for watching.